The empirical formula is just the smallest whole number ratio of atoms in the compound. It is not the formula of the compound itself. That is the molecular formula. The molecular formula represents the actual formula of the compound and how many atoms of each element you would find in one molecule. The empirical formula is just the ratio. So acetylene and benzene are two totally different compounds. Acetylene is C2H2, benzene is C6H6. But they both have the same empirical formula, CH. Because for every one carbon, there is one hydrogen in those formulas. So they're both a 1-to-1 ratio. They both have the same empirical formula, but they have different molecular formulas. Again, acetylene and benzene have the same empirical formula. There's always one hydrogen per one carbon, but they have very different molecular formulas. They're very different molecules. Because they have the same empirical formula, they have the same percent composition by mass, because everything's in the same ratio. When you want to find an empirical formula, there's a couple steps that we're going to use. Step 1, assume you have 100 grams. If they do not give you amounts, then just assume you have 100 grams, because that makes the math a lot easier. And whenever possible, you should make the math easier on yourself. Step 2, we will convert percentages into grams of each element. And because you started with 100 grams, that makes that first step easy usually. Then we'll convert grams of each element to moles, and then divide all of the moles by the smallest mole number to get our ratio. And so let's just do a couple of these. And again, there's a special case. You're not allowed to have fractions of atoms. Atoms have to be small whole numbers, because you either have an atom or you don't have an atom. But you're not allowed to have 0.5 of an atom. So if you're going to end up with fractions, we're going to multiply everything by a number to make sure they're small whole numbers. And we'll have an example like that in a little bit. So, calculate the empirical formula for a compound that is 11.19% hydrogen and 88.79% oxygen. So again, it's 11.19% hydrogen and 88.79% oxygen. Assume you have 100 grams. That makes step 1 easy. 11.19% of hydrogen is 11.19 grams. And 88.79% of 100 grams is 88.79 grams. So because we chose 100 grams, it's super simple to convert from percentages into grams. Then we convert into moles. And again, we need the molar mass to do this. So you need your trusty periodic table. And we convert grams into moles like we were just doing. And now, look at both of your numbers. Which one is smaller? 5.549 is smaller than 11.10. So we divide both numbers by 5.549. And we get a 2-to-1 ratio. So our empirical formula is H2O. That does not mean the molecular formula is H2O. This might be water, it might not. We don't know yet. It could be H4O2. It could be H6O3. It could be H8O4. It could be H10O5. The only thing that we know so far is that the empirical formula is H2O, which means in the compound, for every single oxygen, there will be 2 hydrogens. But we don't know how many of each are in the molecule yet. So we have another one, 56.68% potassium, 8.68% carbon, 34.73% oxygen. Pretend you have 100 grams, and we convert percentages into grams. And then we convert grams into moles. And of our 3 moles, the smallest is 0.723. So we divide them all by 0.723, giving us a 2-to-1-to-3 ratio. K2CO3 again. 56.68% of 100 grams, 56.68 grams. 8.68% of 100 grams, 8.68 grams. 34.73% of 100 grams, 34.73 grams. We convert grams to moles using our trusty periodic table. We look up each element and find the molar mass, and we convert grams to moles. And then we divide all of the moles by the smallest one, which in this case was 0.723, to get our ratio. And we're done. Next one's a good example because you're going to see what to do with fractions. So now they actually give us numbers. When they didn't give you a mass, you were free to choose your own. So that's why we used 100 grams. But in this case, we have to use the experimental evidence. 2.233 grams of iron, 1.926 grams of sulfur. So we convert directly from these grams into moles. So we look up iron on the periodic table, 55.85 grams per mole. We look up sulfur on the periodic table, 32.07 grams per mole, giving us 0.03998 moles of iron and 0.06006 moles of sulfur. And we divide them both by the smaller number, 0.03998 moles of iron, giving us 1 to 1.5. But we cannot have a formula that looks like this. You're not allowed fractions in chemistry. You cannot have half an atom. So this would be incorrect. You cannot stop there. You cannot have 1 to 1.5 because there is no such a thing as 1/2 of an oxygen atom. You either have one or you don't. So in that case, we multiply them both by 2 to get Fe2S3. So when you have fractions, you multiply to get a whole number. You're allowed to round up to 0.05. So if you have 1.95, you can round to 2. If you have 2.98, you can round to 3. But you're not allowed to round more than 0.05. After that, you have to use a number to correct it to make sure they're all whole numbers. Then last topic, molecular formula. If you have an empirical formula and a molar mass of the compound, we can find the molecular formula. So we first find the multiplier. The multiplier is the molar mass of the molecular formula, which at this stage of chemistry just has to be given to you, divided by the mass of the empirical formula, which you can find if you found the empirical formula. This gives us a multiplier, and we multiply the empirical formula by the multiplier to get the molecular formula. So let's do one. A compound with the empirical formula, NH2, was found to have a molar mass of 32.05 grams per mole. What is the molecular formula? Well, we first find the multiplier. You were given the molar mass of the compound, and you always will be in this class, because there's no way for you to find that yet. And then we divide it by the molar mass of the empirical formula, which was NH2, so 14.01 for nitrogen and 1.008 for hydrogen. And our multiplier is 2. So we take the empirical formula, multiply it by the multiplier to get N2H4, the molecular formula. Another example, a compound with the empirical formula NO2 was found to have a molar mass of 92 grams. What is the molecular formula? Well, again, you have the molar mass of the compound that has to be given to you, divided by the molar mass of the empirical formula, which NO2, 14 plus 16 plus 16. Our multiplier is 2. We multiply the empirical formula by the multiplier, and we get N2O4. Propylene is 14.3% hydrogen and 85.7% carbon by mass. So we're going to first find the empirical formula and then find the molecular formula, because they don't give us the empirical formula on this one. So let's start with the empirical formula. Pretend you have 100 grams. Convert percentages to grams. 14.3% of 100 grams is 14.3 grams. 85.7% of 100 grams is 85.7 grams. Convert to moles. The smaller number is 7.14. We divide each number by the 7.14. And we get 2 to 1 ratio. Again, you're allowed to round up to 0.05. So 1.95 and more can be rounded to 2. This is 2 to 1, giving us an empirical formula of CH2. Now we must use this to find the molecular formula. They gave us the molar mass. If you look back, they told us the molar mass of the molecular formula was 42.08 grams per mole. And And we divide that by the molar mass of the empirical formula, which for CH2 is 12 plus 2 is 14, gives us a multiplier of 3. Times the empirical formula by the multiplier, CH2 becomes C3H6, which is propane, or propylene. Calculate the molecular formula for a compound that contains 80% carbon and 20% hydrogen by mass. And they give you a molar mass of 30 grams per mole. Again, we must first find the empirical formula. Pretend you have 100 grams. 80% is 80 grams. 20% is 20 grams. Convert grams of hydrogen to moles of hydrogen. Convert grams of carbon to moles of carbon. Of the 2 moles, 6.66 is the smaller number. We divide them both by 6.66 and we get a 3-to-1 ratio. Again, you're allowed to round up to 0.05. So 2.95 and above can be rounded to 3. So this is a 3-to-1 ratio, CH3. Now we take the molar mass of the compound divided by the molar mass of the empirical formula, which we found to be CH3, so 12 plus 3 gives us about 15. Our multiplier is 2. We multiply our empirical formula by the multiplier, and we get C2H6. Which back here, C3H6 was propylene. Here, C2H6 will give us ethane. And that is the end of this chapter.